Hello, hello, hello. Hello. Hello, hello, hello. Hello. Hello, hello, hello. Hello, hello. Hello. Hello? Hello? to STEMAIDE Insight Series, your number one STEM series show brought to you by STEMAIDE Africa. Every first Saturday of every month, at STEMAIDE we say reinventing the future. STEMAIDE is an edtech company that is on a mission of providing quality STEM learning materials to every individual in Africa. At STEMAIDE, once again, we say reinventing the future. A future where you and I can have practical STEM education at anywhere we find ourselves. In fact, today let's head on to www.stemaide.com for more information. Today marks the first day of our 3-day online exciting workshop, and I'm amazed to be here with you. We are going to be building amazing projects ranging from smart lamp systems, push button systems, and smart security gate systems. In fact, I know this is going to be very, very great. My name is STEMAIDE Joseph. I'm a technology and fintech educator specializing in the field of STEM, robotics, and financial technology. Ladies and gentlemen, let's jump into today's exciting and most amazing time. Without wasting more time, we are going to talk a little bit about what this free workshop intends to do, and then we can jump in. Yes, so with this free workshop, we want to create an impact where everybody can have practical STEM, whether you have a physical component or not. But then, ladies and gentlemen, I want to introduce something to you called the servo kit. This is all-in-one kit that can be used to build over 200 projects. And I will also recommend you to head on to www.stemaide.com for more information on the servo kit. Without wasting my time, family, let's jump in. Today we are going to be working on a smart lamp system. Yes, I mean the smart lamp system. And then I know you can't wait to see which kind of system I'm talking about. Yes, so the smart lamp system is, imagine you walking on the streets and then somewhere around in the evening or somewhere in the evening the light automatically gets on, especially the street light, it automatically gets on, and then during the daytime, somewhere around 6 to 7 a.m. in the morning, it also goes off again. That is what we mean by smart lamp system. Today, we have brought this system live onto our table, and we want to build it together with you so that you can also have the technology idea behind this automatic systems. In fact, imagine you enter your bedroom and then automatically the light switches on, especially in the evening, and then during your daytime you need to work, and then your light also goes off. Have you ever wondered what makes the system works? Yes, ladies and gentlemen, this is the system we are going to build today. Right away, before we jump in, let's look at some components and materials we are going to need in building this project. And let's start with the Arduino Uno. The Arduino Uno is our component number one, just as you can see on the diagram. This is a microcontroller that can contain code and then can be used to run code. This has a whole lot of functionalities of which cannot talk about it today. Also, we look at our component 2, we are going to be dealing with the breadboard. In fact, the history of the breadboard has been a little bit happy and exciting to me, as in when I heard how the breadboard came about. Today is going to be one of our components we are going to use in building the smart lamp system. Aside that too, we are going to be using the jumper wires, that is our component 5. We will be using the LED, our component 3, and then we'll be using the LDR, which is the light dependent resistor. This is, in fact, our sensor we are going to use and to detect whether it's daytime, it's nighttime, whatever it is. Aside that too, we are going to use resistors. And in fact, this are the components we are going to use. But then, ladies and gentlemen, I just want to assure you that there is all-in-one coder kit, just as I spoke earlier. The STEMAIDE coder kit, I have it here with me. This is the STEMAIDE coder kit, and it contains all of these components you can see on this diagram. So head on to www.stemaide.com for more information on the STEMAIDE coder kit, and make sure you get your STEMAIDE coder kit before we end this 3 days online workshop. Ladies and gentlemen, let's jump in. Right away, we are going to jump into our building. We don't want to waste my time, but before we go, I would urge you to help me share this to any loved one you see out there, any loved one you know this is going to be very, very much important to, because sharing what is good and what is bad for your loved ones means that you actually love them. So without wasting my time, I also recommend you to subscribe to this YouTube channel, because we are going to run this 3 days online workshop on this YouTube channel. Ladies and gentlemen, family, let's jump into our building. Yes, so I have with me my Tinkercad, as you can see, and this is where I'm going to be building my smart circuits here with you, and I hope you also follow. But then, those with the STEMAIDE coder kit, I would urge you to also follow. It's still the same steps, just as we are going to build on the Tinkercad software. It's still the same procedure, just that with the STEMAIDE coder kit, you are going to have an advanced version of the LDR. And it's still the same connection, the same wiring, and everything. So, ladies and gentlemen, let us waste no time. Yes, so I'm going to be building this circuit once again with you, just for you to understand how the circuit works. From there, we would also program our circuit, and then we can call it a day for our first day online workshop. And I am believing that you go away with much impacted ideas and much creativity. Also, don't forget to still get your STEMAIDE coder kit, so that you can have this more reality and more hands-on. Thank you. Yes, so let's jump in. Before we jump in, let's look at how this system is going to work. Yeah, so we have our LDR over here, and with this LDR, it's simply a sensor that sends in light, and then you can use this sensor to record the intensity of light in a given area. Yeah, so without much ado, I'm going to demonstrate to you how this system is going to work and what you should be expecting after building it. So, as you can see, you have my, this simply represents darkness, and then this simply represents light. So whenever there is light, you can see my LED or my red LED here going off, and whenever there is darkness, you can see my red LED coming on. In simple terms, we are applying the knowledge of the street lights coming on and off during the daytime and off during the nighttime. So during the daytime and then coming on during the nighttime. So that's the same principle we are applying here. You can see all my components. So I'm going to stop simulating this, and then we build it once again, and then we'll run it. So ladies and gentlemen, I believe you are ready and ready to go. Yes, so we are going to capture our Arduino Uno R3 board. Just as I spoke earlier, this is a microcontroller board, and it's, in fact, I call it a mini computer, a microcomputer, whatever it is. Yes, so I'm going to simply drag and drop this microcontroller here, and then I hope you follow my steps and make sure you don't find yourself wanting. By the way, if you are finding yourself wanting, I have the link to our WhatsApp group in my description, so make sure you jump in and then put up all your questions. I'll be available right after this show to give you all your answers. So I'm going to start with my Arduino Uno board, and then this is my cable. So I'm going to be copying this circuit we have on top here, just as we did the same thing. Yes, so I have my breadboard. So I'm going to drag my breadboard and then put my breadboard just right beside my Arduino Uno board. And then I'm going to start mounting my components. Start mounting my component. Within the STEMAIDE Coder kit, it also has the same thing that you can easily mount your components and everything. So I hope those with the STEMAIDE Coder kit would follow the same steps. And if you are also looking for a physical one to have more physical experience, then I will urge you to head on to www.stemaide.com once again. Ladies and gentlemen, let's continue building our circuit. So I'm going to start mounting my components on my breadboard, and I'm going to pick my red LED first. So I have my red LED just here, so I'm going to drag, and then I'm going to be dropping my red LED just on this hose. I know some of you might be wondering how the breadboard is working, how does it function. I don't want to say much, but then the breadboard has horizontal and vertical connectors. So anytime I'm connecting something within this lane, I'm having it on the vertical connectors. And then anytime I'm having a connection within this vertical lane, I'm connecting it on the vertical connectors. But then these are some of the things we teach at STEMAIDE Africa. So I'll still encourage you to head on to www.stemaideafrica.com for more information on that. Yes, so ladies and gentlemen, I have my red LED mounted on my breadboard, and then I'm going to pick my resistor, and I'm also going to mount it on my my anode side of the red LED. So with the red LED, we have the positive and then the negative. So whenever I hover my mouse around the positive, you can see the anode, and then when I hover my mouse around the cathode, you can see the negative cathode indicated. So I'm going to be mounting my resistor right close to my red LED. That means that my red LED and my resistor are on the same connection. Yes, and I would want it to jump to the next circuit, so I'm going to bring it down a little bit so that I can have one terminal here and then one terminal too on this side. So let's continue with our circuit building. I'm also going to pick my LVR, which is my light dependent resistor that I have up here. So I'm going to pick my LVR and I'm going to mount it on my breadboard. So I hope you get ready to see how I'm going to mount it. So I'm going to pick my LVR, which is normally called a photo resistor. Then I'm going to drop it on my breadboard, actually mounting it on my breadboard. So if you are using the STEMAIDE Coder kit, you are also going to be mounting your LVR on the breadboard, just as you can see we've mounted everything on the Tinkercad software. So you follow the same steps. The only difference is that the STEMAIDE Coder kit contains the advanced version of the LVR, and this is what the pros usually use. So I would urge you to go in for one so that you can also act like a pro. Yes, so ladies and gentlemen, we continue. Now I have my LVR mounted on the breadboard, and I'm going to get another resistor, which is this resistor we have here. I'm going to get one resistor, and not to forget, our resistor has their voltages and then it has their ohms. So for instance, I click on this resistor, it has the 220, it has the 220 ohms, that's what we can see here. So I'm going to change the ohms of my resistance here, the resistance to 220. So I'm clicking on it, and then so I'm going to click on my resistor here, come back and then type 220. So that means that I've set my resistance to 220 just as I have on my circuit here. And I hope you are following these steps. Make sure you don't miss this. And also don't forget to invite your friends and family to join this amazing workshop. In fact, this is just the starting. Yes, so I'm going to look for another resistor. I have my resistor up here and I'm going to mount it to my photo resistor. One thing about the photo resistor is it does not have terminals like a positive and a negative. It is all in the same way. So I'm going to put my resistor on this terminal and then I'm going to literally leave it this way. I would prefer to leave it this way, but then I don't know how you may want to leave it. So I'm going to check for the resistance of this resistor is 10K. So that means that I'm going to make my resistor here 10K. So I have my 10 and then it is already in the kilo ohms. So that means I'm in my 10K. So I'll leave it this way, and as you can see, the colors are just the same thing as you can see on my image here. Yeah, so I'm going to continue building my so I want to rotate my resistor. All I do is to press R and it rotates. I press R again, it rotates. I keep on pressing R till I found the kind of rotation I want. I leave it and then I leave it this way. So now it's time to start to wire my circuits. So let me zoom out a little bit for us to have a look at what we are having here. So I'm going to be connecting my jumper wires all over to my Arduino Uno board. Then when we are done, I will be going to upload the code. Ladies and gentlemen, we have left all code and all source files to this workshop in our Google Drive, and the link to our Google Drive is in the description below. Don't forget to subscribe to this YouTube channel and don't forget to like or share. So we continue to build our circuit, and now it's time for me to start wiring my circuit. I am going to look for my jumper wires. So right away I keep scrolling and then I'll choose to just do wires here, and then I can have my wire here. Maybe I don't like this. I just have to go to components and then I would choose the kind of wire I'm looking for. But then one thing about Tinkercad is the wires are already pre-installed or whatever it is. So if you want to wire a component, you don't have to literally go and search just as I was searching. But then what you have to do is to click from where you want to join your wires and then drag it to the other port or the other connection you want to join. So for instance, I'm going to first connect my green wire from the photoresistor to my V5 hole on the Arduino Uno board. So what to do is that I am first going to click here, just as you can see. When I click, my wire starts following me. So I just left clicked it and then I zoom out a little bit, I go down, I click, and I keep moving my wire, and I'm connecting it to my V5 on the Arduino Uno board, just as I have it over here. So it has been connected. It's my green wire. I've connected my green wire. Now it is time to connect my red wire, which is my other terminal of my photoresistor. So I'll come back down here, click, and then still drag, and then move, click the AO, just as we have over here. So click, I want to do something very neat. So and then I click on my AO hole. Now if you have noticed, the color is still green, and then we don't want color green. So what we have to do is to change the color on top here to red whilst we still select the wire. So I'm going to select the wire and then change the color to red, and then you can see I have my red wire. Now I continue to wire my circuit. I'm going to also make the connections of the terminal we have here. So this black wire is literally connected to my resistor, and then my resistor is also connected to my photoresistor I have here. The reason why we do this is if you are using the STEMAIDE coder kit, you get to have 4 terminals and it's still the same connection, just as this. This has 2 terminals, but then we are making 3 connections on it. So I'm going to make my black wire connection here. So right away I'm going to choose from this hole. I don't forget, I told you with the breadboard we have the horizontal connectors and then the vertical connectors. Horizontal connectors means when I put the power here, it's going to flow right away from here up to this side. It's not even going to jump to the next lane. So right away I'm going to choose my red here, my wire, and then I will keep moving it. And let's not forget, we are connecting this black wire to our GND, which is the ground on the Arduino